In this question, a scientist wants to determine the enthalpy change when 325 grams of butane, C4H10, completely combusts. Our first step is going to be balancing our equation. Now, I'm not going to show how to do that here. I'm going to assume you already know how to balance equations. If you need help with that, go back to Unit 14 to practice. To balance this equation, we're going to need coefficients of 2, 13, 8, and 10. Now from here, this is going to work exactly like a normal stoichiometry problem, apart from we also have the enthalpy change of our reaction involved. So we're given the enthalpy change of reaction here. That's in units of kilojoules per mole of reaction. So what that tells us is that 1 mole of the reaction has an enthalpy change of negative 5,754 kilojoules. So that's the conversion factor we get from our enthalpy change of reaction. So in our stoichiometry dimensional analysis table, we're going to need to start with whatever are given us in the question. Here it's grams of butane. We're going to need to convert that first into moles. Then we're going to need to get moles of that substance into moles of the reaction. So overall in our reaction, if we have 2 moles of C4H10, 13 of O2, making 8 moles of CO2 and 10 moles of H2O, that is 1 mole of the overall reaction. So we're going to be using the conversion factor to the moles of reaction. And then finally, we're going to use that along with the enthalpy change conversion factor here. So let's start by calculating our moles of butane, C4H10, from our grams of butane. So we're going to need to figure out the molar mass of butane to do that. So we're looking for C and H. Here's H. It has a molar mass of 1.01. Here's C. It has a molar mass of 12.01. And we have C4H10. So that's going to be 4 times the molar mass of carbon, which is 12.01, plus 10 times the molar mass of hydrogen, which is 1.01. If we add that all together, we're going to get a molar mass of 58.14 grams per mole for C4H10. So what that tells us is that 58.14 grams of C4H10 is the mass of 1 mole of C4H10. That's what our molar mass tells us. So that's going to be our conversion factor here. We're starting with grams, so we're going to want to put grams on the bottom of our fraction so it will cancel out. And we're converting into moles. And we need the numbers here to be such that the top and bottom of our fraction are equal to each other. So on the bottom with grams, we're going to have 58.14 grams of C4H10, and that's equal to 1 mole of C4H10. So that's our first step, converting grams of C4H10 into moles of C4H10. Next, we want to convert into moles of reaction. So we're going to be going from moles of C4H10 into moles of reaction. So let's find our conversion factor here. So in 1 mole of our reaction, we have 2 moles of C4H10. So that gives us our conversion factor for moles of our substance into moles of the overall reaction. So we've got 2 moles of C4H10 in 1 mole of the reaction. Finally, we need to convert moles of reaction into the enthalpy change. So we've already found our conversion factor here from moles of reaction into enthalpy. So we've got moles of reaction on the bottom, so that will cancel out. We want to end up with kilojoules, and we need to put in our numbers. So 1 mole of reaction results in a negative 5754 kilojoule change in energy. Awesome, so we filled out all our steps. Now we need to go ahead and calculate our answer. So we're going to multiply everything on the top of our fraction, multiply everything on the bottom of our fraction, and divide the top by the bottom. And any units that the same top and the bottom will cancel out. So grams of C4H10 cancel, moles of C4H10 cancel, and moles of reaction cancel. That leaves us with 325 multiplied by 1, multiplied by 1, multiplied by negative 5,754 kilojoules, divided by 58.1, multiplied by 2, multiplied by 1. So if we put that into our calculator, that's going to get us out negative 16,088 kilojoules. Let's try that in our answer box. Awesome. So as you can see, this works exactly the same as any other stoichiometry problem. The two differences are firstly that we're using a conversion factor from our equation between moles of our substance and moles of the reaction. Secondly, we're using our enthalpy change of reaction as our conversion factor between moles of reaction and kilojoules. Some of these questions might use different conversions. So this one had mass. Some might start with just moles. Some might start with a gas volume, or they might start with a solution of a certain concentration. So you'll have to use the relevant conversion factor based on what's happening in the question.